In this video, we're going to look at parallel and perpendicular lines. Two lines are said to be parallel if their gradients are the same. So if we had this line and then we had another line like so, and they never met, we would have the same gradient. We might have another line. Let's go ahead and draw on another line. If I had this line, for example, quite clearly neither of these two lines are parallel to this one as they intersect. Parallel lines will never meet. If we look at that on a graphing calculator, we've got now the line y is equal to x. So the red line has a gradient of 1, so it goes up 1 for everyone it goes across, and it intercepts now the y-axis at 0. This is a line y is equal to x plus 1. If I increase this now, let's say we had y is equal to 2x and y is equal to 2x plus 1. Both of these now have a gradient of 2. So if I wanted to change this, I could still have these as parallel lines. So this is y is equal to 2x plus 3. I could change this one right here, and I could have that as y is equal to 2x minus 2. They're parallel, they will never meet. If we now look at perpendicular lines, we can say that two perpendicular lines will meet at right angles. So if I have one perpendicular line, or one line, and the other is perpendicular to it, we will have now a right angle like so. So if I just go ahead and put that on, these lines are perpendicular. We can say that the product of their gradients will always be negative 1. So let's say that this is m1. This is the gradient of line 1, and this is m2. We can say that if these are perpendicular, m1 multiplied by m2 will be equal to negative 1. A more intuitive way to think about this is that the gradient will be the negative reciprocal. So for example, if I had the gradient m1 and this was going to be equal to 2/3, the gradient of the perpendicular line would be equal to negative 3/2. I've simply switched the fraction up and made it negative. So if I had a gradient of positive 4 for m1, the gradient of the perpendicular line would be negative 1/4. Remember, 4 is just 4/1. If now the gradient of the perpendicular line was negative 7/5, then the other line would be positive 5/7. If we had positive 1/3, it would be negative 3. So we can say that perpendicular lines meet at right angles, and the product, so the multiple of their gradient, always gives -1, or more intuitively, we simply invert the fraction and multiply it by -1. So let's go ahead and look at some perpendicular lines. I'll put another line on. This one now is perpendicular to both of these. So we know that this line, we've already seen that the black line has a gradient of 2. The gradient of the perpendicular line, as we can see it's at right angles, is going to be negative 1/2. And we can see that it goes down 1 for every 2 it goes across. So it's now the negative reciprocal. We can move that up like so, and it will always be at right angles. If I went ahead and changed the gradient now on the line, the original line, we can see the perpendicular will also change. So let's go ahead and do that. Let's put that just there. So what I'm going to do is do quite a nice example of this. Let's just take one of these back to the origin. This is the line y is equal to x, and this is the line y is equal to negative x. They are perpendicular. Gradient of 1, gradient of negative 1, and they both intersect at that point right here. So if we swap this over, we can see now changing the gradients will always give us now the same result. So they are perpendicular lines. Let's go ahead and look at answering some questions. So we're asked to find the gradient of a straight line that is parallel to the line y is equal to 3 minus 2x. The easiest way to do this is put them in the form y is equal to mx plus c. Once the equation of a straight line is in this form, we know that m is the gradient, so this is the gradient, and just jotting this down, and then c is going to be the y-intercept, or the constant. So y-intercept, let's put that on, and that gives us a value. So if I put this line in the form y is equal to mx plus c, y is going to be equal to negative 2x plus 3. So a line that is going to be parallel to this one is going to have a gradient now of -2. If it was perpendicular, it would have a gradient of +1/2. We want a line parallel to this one, so let's rearrange that. I'm going to add the 5y to both sides, so 2x plus 1 is equal to 5y. Dividing both sides by 5, 2/5 x, which is what we're interested in, plus 1/5 is equal to y. If you prefer to write it the other way around, y is equal to 2/5 x plus 1/5. So the parallel line to this will have a gradient of 2/5. The perpendicular will have a gradient of -5/2. If we look at this one, we want a line perpendicular to this one. The gradient here is 3, so the perpendicular, I'm going to write m1 is going to be equal to 3. We can therefore say, therefore m2 will be equal now to -1/3. And I'm going to write now as m1, so m1 multiplied by m2 will be equal to -1 if perpendicular. Later on in your work you will use this notation, but for now it's perfectly fine just to write it would be -1/3. So if you take your studies on further, this is quite nice. m1 is 3, therefore m2, the gradient of the perpendicular, is -1/3, as if we multiply the two gradients we get -1. Hopefully you can see 3 times -1/3 will give you -1. Okay, let's look at the gradient perpendicular to this one. So I'm going to write now that 2y is equal to, subtracting x on both sides, -x, and we're going to add 3. Dividing now by the 2, we're going to have -1/2 x, or -x/2, plus 3/2. So the gradient of this line, m1, is going to be equal to -1/2. Therefore, the gradient of the perpendicular is going to be now m2, which is going to be +2, or if you like, +2/1. We're asked to find in the form y is equal to mx plus c the equation of a straight line A parallel to the line y is equal to 4x minus 1, which passes through the points with coordinates 1, 7. We looked at a couple of different ways of finding the equation of a straight line. We saw that we could use y is equal to mx plus c. We would sub in the values and solve for c, or we use y minus y1 is equal to m, the gradient, x minus x1. I'm going to use, I'll use both on the first one and we'll see what we can do. So we can see now that if this is parallel, so we can write if parallel, we can say m is going to be equal to 4. So a line parallel to this one is going to have a gradient of 4. I'm now going to sub in the coordinates as we did before. The y coordinate is 7. That's going to give me 4, which is the gradient, multiplied by the x coordinate, which is 1, and we're going to add the c. So 7 is equal to 4 plus c, so we're going to have c is equal to 3. We can now put this back together and we can say that y is going to be equal to the gradient, 4x, and then we're going to have plus the constant, or the y-intercept, which is 3. If I'd gone this way, I could have said y minus the y-coordinate is equal to the gradient multiplied by x minus the x-coordinate. So we'd have y minus the 7 is equal to, expanding the brackets, 4x subtract 4, adding 7 to both sides, 4x plus 3. So nice and straightforward, we've just gone ahead and sub that in. Okay, let's do this one right here, perpendicular to the line with equation y is equal to 6 minus x and passing through the point -4, 3. So if we look at this straight off, y is going to be equal to -x plus 6, and that gives me a gradient. We can say m1 is equal to -1. It's got a gradient of -1. Therefore, m2, we want the perpendicular. The perpendicular gradient is going to be now +1. It's just the negative reciprocal. I've got -1/1, and we're going to have +1/1. So we can say that the gradient of the perpendicular is 1, and we can simply sub in these points, -4 and 3. So using y is equal to mx plus c, we can sub that in. So we're going to have now on here 3 will be equal to m, which is the gradient, multiplied by the x-coordinate, which is -4, plus c. This is going to give me -4 plus c is equal to 3, so we can see that c is 7. If I put that back together, we can say now that y is going to be equal to mx, which is just going to be 1x, plus 7. And that is the line perpendicular to it. So nice and straightforward. And again, we could have used this approach, and I will quickly use that approach. We'd have y subtract the 3 is equal to 1 multiplied now by the x, and then we're going to have now, and we need to be a bit careful with this, we're going to subtract now -4. So if I do that, that is going to give me on the right hand side y minus 3 is equal to x plus 4, and then we would just add now the 3, so x plus 7, either way round. With this one right here, we need the line perpendicular to this one through the point -2, -2. So just rearranging this, we can say that 3y is equal to x by adding 3y to both sides. Dividing by 3, y is equal to 1/3 x. The gradient of this line is going to be m1, which is going to be 1/3. Therefore, m2, the gradient of the perpendicular, will be -3. All we would do is simply then sub in the coordinates and go ahead and find that line. So the y coordinate is -2, and that would be equal to now the gradient m multiplied by the x coordinate of -2 plus the c. So -2 is going to be equal to +6 plus c, subtracting 6 from both sides, -8 is c. So we could write the line as y is equal to -3x subtract 8, and that would give us the line. And again, we could put it in this one, this form, and do it like so. Okay, we need to find in the form y is equal to mx plus c the equation of a straight line that is parallel to the line 2x minus 3y plus 5 equals 0, which passes through the points 3, 1. So pretty much the same as we're doing before. These are just further examples. So with this one, I'm going to add 3 to both sides. So 2x plus 5 is equal to 3y. I'm going to divide both sides of the equation by 3. So we've got 2/3 x plus 5/3 is equal to y. This is now in the form y is equal to mx plus c. We can see m1 is going to be equal to 2/3. Therefore, we can say now that the gradient of a line parallel will also be equal to 2/3. So, and we'll just put this here, m2. It's the same thing. So if we just substitute this into y is equal to mx plus c, so y is equal to mx plus c, we've got now y is -1. That's going to be equal to 2/3, and then we're going to have the x coordinate, which is going to be 3, and then we're going to have plus the c. So -1, 2/3 of 3, the 3's are cancelling, that's going to give me 2. Subtracting the 2, -3 is equal to c. Putting the equation back together, y is equal to the gradient, which is going to be now 3/2. Let's just go, 2/3. So 2/3, and then we're going to have here 2/3x minus the 3. And that will now give us the equation. So we've written it in this form. If we wanted to write it in this form is ax plus by plus c is equal to 0. So if I wanted to, I could multiply both sides of this equation by the 3. 3y is equal to 2x minus 9. Subtracting 3y from both sides, 2x minus 3y minus 9 is equal to 0. And that is in the form ax plus by plus c is equal to 0, where a, b and c are integers. Later on in your work, you will see some examples of that. Let's just quickly see if we can find the gradient of this one, and then hopefully you can see that it should be relatively straightforward to do. So 4y subtracting 3x from both sides will be equal to -3x plus 1. Dividing both sides of the equation by 4 will allow me to evaluate the gradient. Remember, as soon as it's in this form, y is equal to mx plus c, we can see the gradient. So that's going to give me 1/4. So we can say that m1, the gradient of this line, is going to be equal to -3/4. Therefore, the gradient of the perpendicular m2 is going to be equal to positive 4/3. We simply invert the fraction and then make it, if this one's negative, we make it positive. So we've got 2, 5, so subbing that in. 2, 5, we can use y is equal to mx plus c. We've got the point 2, 5, so we can write that 5 is equal to m, which is 4/3 of now 2, and then we're going to have plus c. So all I'm doing is simply writing this in. So we've got now 5 is equal to 8/3 plus c. This is going to be 15/3 as an equivalent fraction is equal to 8/3 plus c. Subtracting 8/3 from both sides, 7/3 is equal to c. So I can simply write now that the equation of the perpendicular line y is equal to positive 4/3, so positive 4/3 x plus now 7/3, and that gives us the equation. So as you can see, this is fairly logical. We're finding now the gradient, we're evaluating the gradient. If it's parallel, they'll be the same. If it's perpendicular, their product will be -1, or if you like, the negative reciprocal, and we plug it in. Okay, I think what we'll do to finish is do a couple of questions that might be beyond the scope of the course, but could be interesting nonetheless. We need to find in the form y is equal to mx plus c the equation of the perpendicular bisector of the line segment joining each pair of points. So perpendicular, so that's going to be at right angles. Bisector means cut in half. I'm just looking at these points and I'm just going to draw a quick sketch as I don't think I've got enough space on here. So what we're going to have then is this first point, which is going to be 0, 4. So if I have 0, 4, that is going to be just here. Let's put that just here. So that's 0, 4. And this one is going to be 8, 0. So let's put 8, 0 just here. So we've got 8, 0, and we've got now 0, 4. So if we look now at a line segment, what we can do is go ahead and start to work on this problem. So here's my line segment. So what we need for this, certainly to begin with, is the midpoint. If it's a perpendicular bisector, it will go through this midpoint and be at right angles. So if we build this up, I'm going to have something that's going to look like this. So if we think from our last video on the midpoint, we saw that the midpoint, and I'll just call this m, is going to be now the x's added together and divided by 2. So that would be 0 plus 8 divided by 2, and then the y's added together, which would be 4 plus 0 divided by 2. So what this gives me is that this point right here is going to be 4, 2. We looked at lots of different ways of finding that. You could say to yourself, well, I've gone across 8, therefore I need to go across by 4, and I've gone down by 4, so I need to go across by 2. Let's just put that in place just to make it look a little neater. There we go. So that's the midpoint. If this is a perpendicular bisector, we need to find the gradient of this line. So what I'm going to say is the gradient of this line is going to be m1, and the gradient of this line, the perpendicular, will be m2. We know that m1 multiplied by m2 will be equal to -1 if perpendicular. So let's go ahead and find m1, and I'll just write it here. m1, the gradient of line as we've seen before, is the change in y over the change in x. So if we do the change in y, we're going to have 4 minus 0. So 4 minus 0 over now the change in x, which is going to be 0 minus 8. Remember, I need to remain consistent. If I've chosen this as y1 and this as y2, this must be x1 and x2. So if I look at that, that is going to give me 4 over -8, which is going to give me -1/2. So what we can say then is that m1, so just jotting it here, m1 is equal to -1/2. Therefore, we can say that m2, the gradient of the perpendicular, will be the negative reciprocal of this, which is going to be +2. We now have a gradient and we have the point that it goes through. The only things that we need for the equation of a straight line are a point and a gradient. So a point it goes through and a gradient. So using y is equal to mx plus c, we know that the value of m or m2 is going to be 2, and we have this point 4, 2. We only need these two things. We don't need a y-intercept, we just need these. So if I sub these in, the y-coordinate is 2, then we've got the gradient, which is 2, we've got the x-coordinate, which is 4, and then we've got the c. So 2 is equal to 8 plus c. So subtracting 8 from both sides, c is equal to negative 6. So we can say now the equation of this line right here, which we might see as L2, we can say that L2, line 2, has the equation y is equal to 2x, that's the gradient, and then minus 6. And that kind of looks pretty good, that point right here when it would meet just here, looks pretty good for negative 6, 0, negative 6, and we found that line. So again, that might be beyond the scope of your course, but it's interesting nonetheless. Let's finalise or finish with quite a tough one. The line with equation 2x minus 3y plus 5 equals 0 is perpendicular to the line with equation 3x plus k y minus 1 is equal to 0. We're asked to find the value of the constant k. Let's just remind ourselves that we can put a line in the form y is equal to mx plus c. Once we do this, we can evaluate the gradient. We also know that m1 multiplied by m2 will be equal to negative 1 if perpendicular. So let's go ahead, let's just call this one line 1 and this one L2, line 2. So if we look at line 1, rearranging this in the form y is equal to mx plus c, 3y will be equal to 2x plus 5. I've simply added now 3y to both sides of the equation. So y is going to be 2/3 x plus 5 over 3. There we go. I've simply now divided through. So from this, the gradient m1 we can evaluate at positive 2/3. I'm going to leave that just there. If we look at this one, rearranging this, I'm going to say now that line 2, ky, subtracting 3x from both sides and adding 1 will give us now ky is equal to negative 3x plus 1. Dividing both sides by this constant k, negative 3 over k x plus 1 over k allows us to evaluate the gradient. We can say now that the gradient m2 will be equal to negative 3 over k. So all I'm going to do is look at the property just here. If perpendicular, this one multiplied by this one will give us now negative 1. So 2 over 3 multiplied by negative 3 over k will be equal now to negative 1. If I look at this, I can divide both sides of the equation here by the negative 1. I can cancel the 3 and the 3, and that leaves me now that 2 over k is equal to 1. Multiplying both sides by k, we can see from here that k is equal to 2. So we've gone ahead and solved. So that one might certainly be beyond the scope of your course, but I think it's interesting nonetheless. So there we go, a tutorial on parallel and perpendicular lines. Parallel lines have the same gradient, they never meet. Perpendicular lines have a gradient where their product is negative 1, or we simply invert the fraction and multiply by minus 1. They will meet at right angles. Perpendicular lines, or the normal to a tangent, as you'll later discover, will have now a line meeting another line at 90 degrees.